Okay, so this mini lecture is going to look at sort of this first introduction of forces, how they work, what influences them, what are some ideas we can put into place about a force. And so let's think about what forces do. If I wanted to get something to move, let's say I had a stationary object and I wanted to get it to move. Well, I have a couple of options. I could pull it or I could push it. You know, back when we were young, pulling and pushing, they were opposites. But are they really opposites from the perspective of the object? So, from the object's perspective, if it gets pulled, it changes its motion in that direction. If it gets pushed, it changes its motion in that direction. So from the perspective of the object, a push and a pull have the same effect. So we're going to think about forces in that way. A force can be either a push or a pull. What's important is how they affect the object. So we're going to look at a force, in terms of thinking about it as a push or a pull. How do we get an object to move? And we're going to even be more specific about that. What does it mean to be getting an object to move? What does it mean to cause an object to be pushed or to pull? What does it mean to cause a force? So if we're thinking about getting an object to move, what are we actually doing with that object? Well, we're changing its state. It's going from a state of not moving to a state of moving. When we think about a state of moving, we think about the player of velocity. So in the case of an object standing still and I pull that object or push that object, I apply a force. I am changing the object's velocity. Does that work in all cases where I would apply a push or a pull? Let's say the object is moving towards me and I'm going to push it in that direction. What's it going to do? Well, it's going to slow down. It's going to come to a stop, and maybe it'll come to a stop and then it'll continue to move in the opposite direction. So stopping an object by a push or a pull changes its velocity. What if an object is moving along happily and I push it in the same direction it's moving? It's going to get faster and faster and faster. So getting an object to go faster is changing its velocity. So we have a variety of different things that cause changes in velocity and can be defined as sort of this push or pull. So let's generalize that a little bit. This change in velocity occurs over some time course, some time that the force is interacting. And so if we think about a change in velocity during a time that the force is interacting, this should look awful familiar to you. This should look like an acceleration. This is our definition for average acceleration. And that's just what a force does. A force causes an acceleration. An acceleration is a change in the object's motion. And so a force causes a change in motion. Now, that might seem very intuitive, but what I want us to be very, very careful about is that we always remember that it requires a change. So let's write that down, that a force causes a change in motion. And we know there's a way to describe that. That's an acceleration. When we learned about acceleration, we learned that they could be speeding up. So a force could cause an object to speed up. An acceleration could be slowing down. So a force could cause an object to slow down. And an acceleration could do one more thing. It's a change in velocity, and velocity has a direction. So if I just change an object's direction, I'm actually changing its velocity. So a force can cause a change in direction. All three of those things are possible with a force. Well, what if the object's moving at a constant velocity? What about a constant velocity? Is there a force required for an object to move at a constant velocity? Well, if we look at the fundamental definition of force, it's a change in velocity. It's an acceleration. It's speeding up, it's slowing down, or it's changing direction. A constant velocity, well, there's nothing changing. So there is no need for a force for an object to move at a constant velocity. The object had to get moving. That would have required a force. But to keep moving, it no longer needs a force to keep moving at a constant velocity. There's one sort of catch to this. We want to think about how forces interact with one another. And this force causing an acceleration is important. It may not just be one force that's causing the object's acceleration. We will look at a variety of forces that cause an object's acceleration. So a force has the potential to cause an acceleration. An object will have an acceleration if the total forces, the total net force is non-zero. It will then have an acceleration. So in a subsequent video, Newton's second law video, we're going to look at that idea of net force. We're going to look at what influences the acceleration that a force does cause. And we're going to explore the property of forces in a little bit more mathematical sense. Good job.